This is okay, the challenge is to find all the different angles inside this triangle here. They're mentioned in here, but we're going to find them all. And we're told that A, B, C is an isosceles triangle, and we're told that A is a radius meeting this tangent DC here. So let's get down to doing this. Now, okay, this is it blown up. Since this is a radius touching a tangent, we know that this angle here is 90 degrees. And obviously the same side over here as well, that's 90 degrees as well. And if this is 26 degrees, well then this bit in here that I'll do in green, that's going to be 64. Now, if I draw an isosceles, another angle from O down to B, okay, well then obviously this is an isosceles triangle too, because this is a radius and this is a radius. So therefore this angle here is going to be, I'll do it in green as well, it's 64 as well. And if it's 64 and this one here is 64, that's 128. That means that we have 52 is this angle here. That's 52. And if it's 52, it's twice this angle up here. So this angle here is 26. And if this angle is 26, well then this angle down here is going to be 154. I think it's going to be 77. So it's 77 degrees, and it's isosceles, so this is 77 as well. I'm just double checking. 77 and 70 is 140, 154. That's right, 77. But we also know that this angle here is 64. So therefore, this little angle that I'll do in red, this one there, that's going to be 77 minus 64 is 13 degrees. Okay, and notwithstanding any little calculation errors I made here, I hope you have the strategy to do that one. Okay, let's have a look at the next one. Okay, you'll notice there's a lot of information given in this. There's a cyclic quadrilateral. We have this angle here. We're told that ST is parallel to PR. So things like, I know that this angle 70 is going to be the same as this one right up here because it's parallel to it. And we know that SV is equal to VT, so SV is equal to VT. So we're now talking isosceles there as well. And we're told that different points on the lines, we're given these two angles as well. So there's a fair bit of information here that you incorporate when you're doing the question. Make sure you go back every now and again if you get stuck and read the question again and see if there's more information in it that you haven't used yet. Okay, so that's a strategy. As I do this question, I suggest every time you get another angle and some extra piece of information, pause it and then try to do it yourself, and then see, we can work on it together then. Okay, let's start. Right, I suppose we'll all probably start in different positions, but I'm going to start off with this one here. This here is 70. And I know it's 70 because I remember that this line here is parallel to this line here. So therefore that's going to be 70. And interestingly, this angle here, when we get it, will be the same as this angle in here as well. Okay, the first thing I notice, well, I'm going to fill in some information, is this is an arc. And therefore, this triangle here, and the angle that it makes up here, will be the same as this angle here. They're going to be the same because you can see the triangle that's built on the same arc here and here. So those two angles are the same. What else? What other arc do I have? I also have, here's another arc. I'll do it in here's one. I know that this angle is the same as this angle. So there's 36. That angle there is 36 because they're standing on the same arc. Right. Any other angles 36? Let's look at this arc here. Here's an arc as well. And I see that this angle here, which is built on that arc, is the same as this angle here. So that's going to be 70. I'll do it in green. I'll do it in green because I can do color coding on this thing, which is kind of nice. Okay, I've now just realized that I'm going to use my isosceles triangle. I know that we were told that this length here was equal to this length. Therefore, this is 36 and this is 36. And if this is 36, well then this one up here is 36. And now I have this angle here. And now that I have this angle, I have this angle. And then I'm going to have these two angles because they add up to 180 and blah, blah, blah. And then I know what this angle is as well because these two, in the total of these two here, being a cyclic quadrilateral, that this angle in here plus this angle here have to add up to 180. And equally, these angles here and these angles here have to add up to 180 as well. So that's this particular problem solved. I can also work at this angle because I have 70, 36 and 36 is 72, so I have this one. I haven't checked the answer in the back of the book, but I think that's the right strategy. I think we have this one solved now. So I think these are the techniques we had to use to solve this. We had parallel lines for this. We had angles standing in arcs. There were 3 different arcs we used to sort of get angles. That was a big one actually, wasn't it? Isosceles, then we had this isosceles triangle and this isosceles. That was the only isosceles actually, there and there. And then we had cyclic quadrilateral as well to get, we know that the opposite, both of them have to add up to 180. Right, hope that helped. Cheers.